the survey?
Yeah, sure will. Thank you.
All right.
Thank you, guys.
All right. Hey, everyone. It is 1 o'clock, so I hope everyone can hear me okay. Um, there's a few people coming in still, so I'm going to give it a little bit of time for everybody to get in and set up for the webinar. But welcome to DesignSafe's webinar. This is, I think, our one this semester. And I think it's going to be the last one for the year. So I hope everybody has had a safe 2020 so far. All right, so I see a few more people in. I'm going to go ahead and get us started then. Hey, everyone. Welcome to DesignSafe. Welcome to our DesignSafe webinar series. I think this is number 3 or 4 for the semester. I'm glad you guys could join us this afternoon. I hope everyone's had a very safe 2020 so far. So let me give you a little bit of background on DesignSafe, some introductions, and some characteristics and new features. And then we'll go into our tutorial for the day. So might help if I can click through. All right, so first off, today's topic is going to be leveraging DesignSafe with TAPIS. The reason we find this important is there are a lot of features that DesignSafe has that are more or less behind the scenes features, but you as users of DesignSafe and researchers can take advantage of these features to essentially to help your research work. And that's what today's topic is about, is essentially using TAPIS to um, help you expedite, to help you understand your research work and take advantage of DesignSafe in new ways that you may have not done in the past. I also want to notice that on today's DesignSafe homepage, there is the inaugural DesignSafe Dataset Awards. So if there is a dataset that you have found to be extremely useful or has proven to be very powerful and very worthy, go ahead and nominate that data set for our DesignSafe Dataset Award. And so if you have more information on that, go ahead and go to DesignSafe's webpage and click on the link. All right, so my name is Charlie Day. I'm the Director of Training, Professional Development here at the Texas Advanced Computing Center. I'm also the training lead on DesignSafe, so you'll probably see some of my videos on the DesignSafe channel, on some of the tutorials we do, and some of the quick start guides we put together for you. If you have any questions on using DesignSafe ever, you can always go to our DesignSafe YouTube channel where we have all of our webinars, all of our tutorials, and a bunch of quick start tutorials and quick start guides for your convenience. All right, so what is DesignSafe? So for those of you who are new, DesignSafe, our vision was to create a cyber infrastructure that would be an integral and dynamic part of your research and your research discovery. It is essentially a set of cloud-based tools. These tools are designed to help you with your analysis work, help you with your visualization, and integrating all the different data types that you use in your research. The idea is, we can use these data analysis tools to unlock big data. Something I always like to say is data only becomes knowledge when you can actually understand what the data set is trying to tell you. And to do that, you have to be able to have some proven tools that can support, analyze, and visualize that data. And that's where DesignSafe comes into play at. We also want to support the end-to-end research workflow, the research cycle. What we mean by that is when you first try and understand what your research is going to do, what the data set is going to be when you first conceive of your idea. We want you to be able to do that on DesignSafe's platform. And then, of course, as it goes from conception and into analysis, into work, and into research, and into actual data, and you publish it, where DesignSafe is essentially going to be there with you with the tools to help you all the way along to actually be able to publish your data, publish your research work through DesignSafe. And of course, NERI, there's lots and lots of different NERI components, and for that support the natural hazard community, and DesignSafe plays a important role in that. But we also want to make sure that we link the capabilities of all the other NERI components under one umbrella. So how does DesignSafe do this? Well, so DesignSafe is split up into a couple different parts. The data depot is essentially what plays the most important hub of our entire workflow. There's a simulation, there's experimental research, there's the rapid research, and then there's our workspace as well. Uh, and they all tie back to the data depot. So data is very important to DesignSafe. And then once you have your data in there and you're ready to publish, we give you tools to curate and publish that data set. So our data creation philosophy, we want to allow users to easily store, share, document, and publish their data sets throughout the lifetime of the project. All right. So it's not that you create a data set and you upload it to DesignSafe and forget about it. No, we want you to actively use that data set. We want that data set to be live. And to do that, and to give you that live data that you can work with, our data models have to be flexible. And that was probably one of the key features of DesignSafe, is to make sure that that data model is flexible enough to support whatever data model you use in your research. So essentially, we're allowing the researcher to decide what best represents their data, right? How to best represent their research. And we want to be able to what is needed for data to be understandable by an outside user too. So what may be best to represent your data may not be the best for someone to understand your data. So we have to essentially play a role in that as well. And then, of course, how do you categorize your data sets as well, and the different parts of your data? Say, is it a model or part of a sensor or part of an event that's occurring, or is it analysis or report or visualization? And so those all come into play. So the curation publication model, we have the data models, we have our experimental simulation, other hybrid simulation, we have the field reconnaissance, we now have the social sciences represented as well. And of course, we can help you develop other models for your research community as well. If you have any questions on how to curate your model, we have a data curator on site in Dr. Maria Esteva. She's a great person to work with. She has open office hours on Tuesdays and Thursdays at 1 p.m. You can go ahead and check DesignSafe site for the link directly, but there's a link listed. But what she's going to help you do is essentially define what your category tree would look like for your data set. What are the major categories? What are the minor categories? How does the data relate to itself? How do the categories relate to one another? And then assign those categories to your individual data files, right? So what file is representative of what data set, and how do you go through and categorize that? And then once you have that all set up and ready to go, we can help you publish your project and your data files. And by publishing, what essentially we're giving you is a DOI, a document object ID number. And with that, you can cite your data set. So once again, the data models are experimental simulation, other hybrid simulations, of course, and the field reconnaissance. And I'm sorry, this slide does not have the social sciences as well. So what our main goal is to make your data count. We are essentially in the realm of big data, and more now than ever are we seeing exactly how data affects our lives. So the idea is we want to make your data count. DesignSafe is pushing for that. And so we want to help you formally publish your data sets just like you formally publish your research work. We'll give you the permanent digital location. It's not just a URL, but this is a ID that essentially follows your data around for essentially the rest of the life cycle of the data set. And then, of course, you can formally cite that data in your references as well. So here's what it kind of looks like. We have a data set for this project. The data set gets an ID. You can click on citation, and it'll give you a citation immediately that you can now copy and paste into your reference list. Okay, so there's many ways of getting your data into DesignSafe. There is, of course, the standard data depot that I'm sure all current DesignSafe users are very familiar with. You can also upload your data through Jupyter Notebooks as well. Though we recommend that you use directly linking to the data depot or uploading to Jupyter, you keep your number of files small, 25 or so, and the file sizes to be about 100 megabytes or less. You can also directly link to Box, Dropbox, or Google Drive, or those are the main cloud platforms right now. And you can sync folders to those environments and have those linked into your data depot as well. And then, of course, there's Globus. Globus is probably the ideal way of getting your data sets into DesignSafe, but there's a lot of working gears in there. So there's a lot of things you have to kind of get precisely set up. And there's actually a quick start guide on getting your information set up for Globus. And there's also a transfer guide that we have linked on this slide as well to get your data into Globus and used. Excuse me. And of course, for those of you who are very familiar and comfortable using the command line, there is a command line interface as well to get your data into DesignSafe. All right, so with that, let's go ahead and get started with our today's tutorial. So today's tutorial is leveraging DesignSafe with TAPIS, and our presenters are Julia Looney with TACC and Pedro Arduino with the University of Washington. A little bit of background. So the TAPIS platform is developed here at TACC. It's an open source service, science as a service API platform. So you hear all about these as a service platforms, infrastructure as a service, for example, and science as a service is something kind of new. Essentially, it's an API that allows you, we're building a bunch of interfaces and commands that you can use to essentially leverage your science onto a machine like TACC's Frontera. So it's an API platform for powering your digital lab. TAPIS allows you to bring together your public, private, and shared high-performance computing environments like Frontera, high throughput computing, cloud computing, and big data resources under one single web-friendly REST API. All right, so DesignSafe is built upon this TAPIS framework, and there's a lot that DesignSafe has to offer by understanding how TAPIS works. So that is the point of today's webinar. And then afterwards, we have Dr. Pedro Arduino, who's a professor at University of Washington. He is works very he is strongly linked to DesignSafe, and he works with our with the DesignSafe team, and he is going to show you a real-world example of using TAPIS and Jupyter Notebooks for a real-life example research project that he's working on. All right, so Julia, I'm going to go ahead and hand this off to you. Thank you so much.
Cool, thanks, Charlie.
And let me stop my share.
I'm going to go ahead and share my screen. All right. So before we begin, I would like to apologize in advance for any dog sounds that you hear in the background. Okay, so Charlie already kind of mentioned it, but for this tutorial, we're really going to kind of take a nice little overview of TAPIS and kind of what it is. So in this talk, I will briefly introduce TAPIS at a high level, discuss what APIs are and how you use them, and then introduce the REST architecture, which is what our APIs are built on, and then show some use cases for TAPIS. So kind of one of our motivations for creating this project is to really nail down these concepts. So we want our things to be portable, reproducible, and be able to scale. So, you know, for example, sorry. For example, sorry, I really apologize for the barking. Okay. So yeah, we want it, for example, we want something to be reproducible. Like we want to be able to run an experiment multiple times in the same environment so that we can produce the same result in different environments. And the tools that TAPIS is made up of is, it's mostly just a set of APIs. And we use containers to encapsulate these services. Yeah, so I'm not sure we'll use all of these today, but these are kind of one of the four basic kind of use cases for TAPIS. So there's identity and access management. So this is done through OAuth 2. When Pedro shows you his Jupyter Notebook later, he'll show you how it's actually quite easy to authenticate within the DesignSafe Jupyter Hub. And then another use case that you'll also see later is finding apps and using apps, as well as managing data and running jobs and code. So Charlie he already kind of mentioned what TAPIS is, but really on a high level, it's basically just a framework to support science in any domain, so that you don't have to stand up all these tools yourself. And on a more technical level, it's really just a set of APIs with authentication services and databases to record and do all the actions of a user. So computing jobs, dealing with files and data, and that sort of thing. And it's all hosted, not on your computer. So it's hosted at TACC in our cloud. And so here's kind of a little diagram for those of you who like diagrams, of kind of how TAPIS manages the infrastructure on your behalf. So you make requests that come to our TAPIS services here. So this box here represents all of our TAPIS services. We almost kind of like to think of it as a middleware. So it kind of sits between, you and your science. And we also have it, we support, we store relevant data. So, like metadata and, job results and that sort of thing. So why would you want to use TAPIS? So you can track your analysis. So TAPIS records, TAPIS records your inputs and output data each time you run a job. So you can go back and see like what your job produced each time. And similarly, you can reproduce your analysis, and it also gives you the ability to share your work with others. So how do you use TAPIS? Well, we have several different ways. So first of all, you can use curl on the command line to call the HTTP APIs. We also have a CLI, a command line interface that you can install and run, on your terminal. And we also have software libraries. So, for example, we have a Python library called TAPISPy. You'll see in Pedro's example that the version that we'll be using today is actually uses TAPIS's old name, which it used to be called Agave. So if you see Agave, just note that will eventually turn to TAPIS. And then we also have web applications like science gateways that allow you to use various TAPIS services. And today we're mostly going to be focusing on using the Python software libraries. So one kind of example of a workflow So you want to run an image classifier on data from a remote server on an HPC system and archive it to your collaborators. So you know about all the servers, and you defined a TAPIS app to do this. So to launch this, you would just tell TAPIS, okay, here's my app that I want to use. And then you tell it what system the data on. And then then you can run the job and it will get saved to the system. So that's basically all you have to do. So after you define that, you send it off, and then TAPIS handles the rest. So it moves the input data and it bundles the app and it sends it to the supercomputer. It schedules the job, it monitors progress, and it tracks the entire process along the way and allows you to view it at any time. So just another example of people who use TAPIS, and you can see DesignSafe is one such group that uses this. But yeah, we have quite a few really interesting use cases for TAPIS at this point. And like I mentioned before, it's used in a lot of gateways. So some of you might find some of these gateways a bit familiar. And it's across many different domains as well. So you've probably heard me talk about, we use APIs. It's just a set of APIs. Well, in case you didn't know what an API is, it stands for Application Programming Interface. So it basically just allows for two pieces of software to communicate with each other. So if you can kind of, if you think of like a web page, that's a user communicating with software. And so an API is when software communicates with software. And so an API also defines the rules for what kind of communication is allowed. So TAPIS, the one TAPIS uses is based on a REST architecture and uses HTTP. So much like your web browser uses HTTP as well. So a REST API has specific rules or protocols for HTTP and URLs. So basically you similar to like when you use a web browser, when you load, let's say, DesignSafeCI.org, you're making an HTTP call to that website. And so an API is basically the same way, except, instead of using a web browser, you would use, like a curl statement or command line. But basically there are four main basic HTTP verbs, is what we call them, in order to interact with a REST API. So there's post, which will create a new resource. There's get, which will retrieve a specific resource. So just as an example, again, if you went to DesignSafeCI.org in your browser, behind the scenes, your browser is actually doing a get request to that. So similarly with an API, if you do a get request, you might get some information back on, what status your job is currently in. Put, we use put for updating a particular resource, and then delete obviously is used for deleting a resource. So yeah. Yeah, so some ways that TAPIS helps manage data is we have systems, files, apps, and jobs. So basically what you do is you register a storage system and a compute system, and then you can ingest, move, and transform data files and folders, register applications on large systems, and then launch jobs to invoke the applications. And then the metadata about those jobs will get saved to your file system. So I've talked about, curl and command line and APIs. So this is kind of this is an example of how a curl statement might look for someone who wants to create a job in TAPIS. So here, for those of you who are not familiar with curl, you start your command with curl, and then this -h means you're adding a header. So the first header we add is for authentication. And so, your token would be replaced here, and your token basically just identifies you to make sure, you are. And then we're going to send in JSON, which is JavaScript object notation. It's just a way of formatting data. So we send in another header saying, okay, we're going to send you some JSON. And then this -d here, this is specifying the actual data that we're going to send in. So here we can see the name of our app. And in the previous example, I mentioned the image classify app. So here we have our image classify app, and then the name of our job, if we want to archive it, and then here's the parameters. So, this is an image classifier, so we're sending it an actual image file. And for those of you who have ties with the University of Texas, you might have an idea of what this picture is. But yeah, so in the data, our app is expecting to get an image file, and then that's all this particular app needs. And then we give it the URL. This is the most important part. We give it the URL that we want to send this post request to. So since we're sending in data, curl automatically knows that this is going to be a post request because we're going to be creating something given this data. So once this happens, TAPIS, it hits this endpoint, and then TAPIS knows what to do. It unpacks all this JSON, it looks for this app, gives it this information, the parameters, and then it'll go off and send your job. So here are some examples of get. So as you can see, there's a lot less going on here. So again, we authenticate, and then you might notice same endpoint, but instead of sending it a job, since we're doing a get request, we're not sending in any data. It's going to tell us, the details about all the jobs that we have. And then if we want to look at a very particular job, we could give it a slightly different endpoint where we do slash and then the job ID that we were given, and that will give information on just that particular job. So that's kind of how curl works. Again, we won't be using curl today, but just kind of gives you an overview about how we use it with TAPIS. And also, I mentioned JSON, and this is something that we use a lot in TAPIS for defining data. So, like I mentioned before, it stands for JavaScript object notation, and it's basically just a format of putting your data in. That's easy, relatively easy for humans to read, and it's also easy for computers to parse and generate. And it mostly focuses on key and value pairs. So for those of you familiar with Python, you might notice that it looks kind of similar to a Python dictionary. And it's the same concept. So, you have name, the app name, app ID, and the app ID. So, it's just a list of key and values. And so just a little bit more about JSON. It supports 3 basic types. And this can get some people if they're for example, it basically just supports string, numbers, and Booleans. And of course, the complex ones such as array and object. And you might note that it does not do timestamps or date objects. So that can be a little tricky at times, at least for me. But yeah, so that's a little bit on JSON. And then similarly, so I just talked about sending data with JSON, but when you get data back from TAPIS, it will also be in the format of JSON. So this is an example of, it looks like I wanted to see the details of my jobs, doing a get request here. And so I can see, this is what comes back. So I can see, okay, it was successful. This is the ID. This is what it was called. And currently it's queued. So, I might have to wait a bit. And that is kind of my quick overview of what TAPIS is. And so if you would like to learn more, you're welcome to go to our website, tapisproject.org. You're also welcome to contact us on Slack as well if you want to know anything more about TAPIS. That's I will turn it over to you now, Pedro.
Okay, thank you, Julia. That was a very good introduction to TAPIS, and I think it fits well with what I wanna do right now. So I will share my screen. I think I am already done that. So do you see that? Do you see the screen? Just wanna make sure.
Yes, we see.
And you can hear me? Okay. So again, my name is Pedro Arduino, and I am a professor at the University of Washington. I am a civil engineer. So I am an engineer, and I am kind of a user of some of these technologies. And so what I want to show you is kind of an example on how to use this app, how to use TAPIS a little bit in the framework of a Jupyter Notebook. So I will put everything in the context of a problem that I consider, but I want to make sure that you understand that this is not just specific for this problem. It can be customized for any other problem. So imagine that we have to do an analysis of something. In this case, what I am trying to do is to propagate waves from the bottom of a soil profile. So oops, I didn't want to do that. I wanted to do the highlighter. Okay, sorry. And why is this color? No, that's not the highlighter. The laser pointer. So imagine that you want to propagate a wave from the bottom of a soil profile. So you want to go all the way from the bottom with a signal to the surface. So it's a typical problem in geotechnical engineering. And for that, we want to do a finite element analysis. Imagine also that we may want to know what happens in the middle of a layer there. For example, you want to know the pore pressures, you want to know the stress-strain behavior there. So what would be the workflow of an analysis like this? So the workflow would include to run a finite element analysis, maybe OpenSys, could be LS-DYNA, could be Abacus, could be any other finite element program that you want. Here I will use OpenSys. Then I want to post-process the results. So once I have the response, I want to post-process in the form of plots, maybe another table that summarizes things. And possibly once I have all those plots and everything, I want to create a report. And I want that report to be kind of automatic. That would be useful for the case when you have thousands of cases and you don't want to go one by one. Maybe you want to say, give me a summary plot of everything. Create a report. And then, of course, I want to do some exploration of some interactive tools that may be useful also when I am using these apps or when I am using a notebook. So in that context, imagine this is the workflow and that I want to handle for this particular problem that I call free field analysis. You can call it building analysis. You can call it dam analysis. You can flow of water analysis, whatever it is, the problem that you are doing. We are going to do that in a notebook. So I will be using, for this particular problem, a Jupyter Notebook. So in this Jupyter Notebook, I will need to run the OpenSys analysis of the finite element. And for that, I will use one of these apps that Julia was talking about that is implemented using the TAPIS infrastructure in DesignSafe. For the post-processing, I can use MATLAB. I will be using Python. That's one of the possibilities. For creating the report, what about using LaTeX? That's a typical thing that is commonly used in scientific publications. And then for the interactive plots, I will again be using some Jupyter capabilities and some Python capabilities. So this is just an example. So before going there, let me give my appreciation or my explanation of a TAPIS app that fits exactly what Julia said before. Imagine that I want to run this analysis in the internet. That's where I am. That's where I live. This is my computer right now that is connected to the internet. And suddenly I have access to this incredible infrastructure. This incredible infrastructure is TACC. And inside TACC, I have access to one of the machines in TACC. For example, Stampede. There is another one that is called Frontera. There is another one that is called Longhorn. So this is the machine. So in this machine, imagine I have these compute nodes. I have where everything is happening. That's the factory. Things are happening there. Now I access in a login node. And this login node is where I have to say, I prepare my case and I send that to this factory. So I create the batch activity. And of course, I will have access to a certain execution system, and I will have access to a certain storage system and certain memory and so forth. So the problem is that I have to bring my little problem into this monster machine. How do I do that? Well, one way is to use command line through, for example, SSH. So typical done, and then you have to go into these queue systems using a Slurm or some other tools. And that's very commonly done. We do that all the time, but it's complex. So it's a little bit complicated. You have to know what you are doing, and you have to connect to this system. You have to authenticate by yourself, and you have to open a terminal. You have to do all that work. It's possible, and actually, I do that all the time. Now, what we can do instead of this is to have something that help us communicate with this monster machine. And those are apps, APIs, sorry. So API is an application programming interface. And there are many of those. You use them every day. Every day that you get COVID data from, I don't know, from Johns Hopkins, you are using an API there that goes to that machine, gets the information, post-process information, and returns that to you. So it simplifies the process, actually. So now, in these APIs, there are many things, but one of the things that are inside the APIs are the apps, the applications. And of course, you have jobs and you have other things there. But when you look at an application, there are many of these applications. Inside the application, you can put a typical code that you want to use. For example, OpenSys, LSDyna, Abacus, any code that you have. But we have some inputs and parameters. And inside this app, you also tell, I want to use a certain execution system. I want to use a certain storage system inside that monster machine. So it really helps make the communication with that machine. Now, it's not only the communication to the machine, it's also the communication to you. So how do you communicate to this with this app? That's the beauty of this, that these TAPIS APIs are generated or are designed so that you can communicate to them either using the internet, just HTTP, or you want to have your own C++ code in your machine that suddenly you say, go and connect to this API. You can do that through curl. That's what Julia was showing a little bit. What about using Python? Yes, Python, if it has been implemented in the API, you can use that. And that's what we have with some of the applications in TAPIS, using TAPIS PI. Jupyter Notebooks, yes, that would be a possibility. And also what is called the command line interface. This is another way that helps simplify your communication with the API so that the API can go into this monster factory that you have there. So is that communication between these systems. Now, for example, for OpenSys, I have to keep my mind, I have to run this thing for OpenSys. Are there apps for OpenSys in TAPIS? And the answer is yes. For example, there is one that is called an OpenSys SP application that allows you to run OpenSys SP. So now you need to know a couple of things. For example, you need to know the name of that application or the ID of that application. And in this case, it's called all this name that you have here. You also need to say what is your input. And the input for this is just the input directory. Where do you have the data? You have also to tell some parameters. For example, for this application is the TCL file that you are going to be running in this OpenSys. And then there are a couple of other things that you have to define, like the batch queue, the type of queue that you are going to be using, the number of nodes, the processors per node, the memory per node, the maximum runtime. You want to run this for half an hour, for 1 day, for how long you want to keep these nodes. And also, do you want to archive the output, or you don't want to archive? And there are examples on this, how to set these things so that you simplify, and I will show that in a minute. So now, in order to access these apps, you can either use the CLI. The CLI, command line interface, is command line, so you have to use your keyboard. And for example, let me show you an example. Let me see if I can do this. Here I am in TAPIS already. So exit. Let me see if what happens if I do exit. So here I am in a command line. In my computer, I say TAPIS. I have installed the TAPIS CLI, so I have access here to TAPIS. So now I am inside, and for example, I say apps list, and that will give me all the apps that are available in the TAPIS CLI. So you see here is producing all the applications that, for example, for OpenSys SP, this is the ID that you have to use, and so forth. So I can access that from there. I can also access that from the portal. What do you mean the portal? Well, what I mean with the portal is that every time that, for example, you are in the portal, and let me see if I can show you this. For example, when you're in the portal and you have chosen OpenSys, this portal or this particular page is actually preparing all the information that you need in order to run that particular TAPIS API or application. So that's an important thing. What about using a Jupyter Notebook? Yes, using the Jupyter Notebook, you can also do that. And that's what we are going to, I will show you in a minute, how to access this app from a Jupyter Notebook. So now, are there any other apps for OpenSys? The only one that you have is this one, OpenSys SP. No, there are several that have been implemented in TAPIS. And here I just give you a list of all the possible ones that are available. It tells you what's the ID, and also tells you the particular OpenSys that is running. For example, OpenSys SP, OpenSys MP, the version of the code. And it also tells you in which execution system. Once you start learning a little bit, you say, oh, I will be running in that machine in the Stampede, or I will be running in Frontera. You need to know where are you running in this big factor. So now, one important thing about this that confuses always me. So imagine this application, this app, and this app is going to communicate with the client. The client is you through the website. And imagine that it's going to ask you for the job description and the files that you want to run, the input file and so forth. Now, what the TAPIS app is going to do is to get this information that you are passing, these input files that you have, and it's going to send that through the app to the big machine. In the big machine, in particular, all the information in the directory is going to be copied into another folder that I call the execution folder. That's where the big monster comes and say, oh, I have this folder, I do all the runs here, I take all that information, it does all the run, and then it's going to write things into an archive folder. Now, this archive folder is not the same as this folder where you have information. So you have to be careful here, because when you are looking at the output, you need to know where is the output. And yes, you can set up your app or your work so that you can tell the program where to go, but in general, it's go to a folder that you have to look for. So that's an important thing to keep in mind. Okay? So now, the folder is not the same as original in general. Let's go to the Jupyter Notebook. So in the Jupyter Notebook, I have here the description of the notebook, what it does. So it's basic information. And then I go to the setup. This is the most important. These two slides are very important because they tell you how to set up your system so that it runs the API. And what it does is first to identify the API that you want to use. So it has the app ID. Also identify in which storage system you want to put or you want to run this thing. Then it also asks for a couple of basic questions, batch, which queue you want to use, the job name, that's any name, the number of processors, how long is the maximum runtime, and everything is spelled out. And in this example, you can take ideas. You have also to define what's the input file that you want to use. And in this case, it's called free field effective TCL. That's what I have the input file for OpenSys. And then you put everything into inputs and parameters. And once you have all the information in place, is where you really have what is called the job description. You put everything that is needed for this app to run, and then boom, you say go, run. Okay, so and when it runs, the only thing that you have to say is, instead of now using when you're using TAPIS, you say, you have a job. And in this job, all that you need to do is describe in the job description piece of information that you have just created here. So you pass all the information and you say, do the job using Agave. And then you say from Agave, one disclaimer here. You will see that in a lot of what I have, instead of talking about
Hey Pedro, I can't hear you anymore.
Can you hear me now?
Yes, you're back.
Sorry about that. From time to time, my microphone goes away. So once you have set up the system, what you have to do is to send that job to the system using the command jobs. And I was mentioning that you will notice that I use a lot the word Agave Py instead of TAPIS Py. Is exactly the same. A couple of years ago, this API was called Agave. Now it's called TAPIS. So if you replace the word Agave by TAPIS, it's exactly the same. So now let me show you that for a minute. For a minute, I will go to Agave here. And so imagine that I am here inside already DesignSafe. And imagine that I want to run this. So for example, I say I want to start Jupyter. So you start Jupyter from the tools and applications. You go to data processing. And you say, I want to run just a Jupyter. And you say launch. So when you say launch, actually it's going to open now Jupyter Hub. Now this Jupyter is run in Stampede. And here you will have all the data that you have available. In this particular case, I will go to my projects because I know that I have something there. And I will go to one particular project, which is this 2812. And here I have several of these notebooks. In particular, I have one that is called the free field effective. This is the one that I've been talking about right now. So once you get there, you will notice that I have all this is the information that I need to run the tool, I need to for doing the post-processing, for doing the report, and so forth. And here I can open the notebook. So here I have opened I am opening this particular notebook, and here is where you see all the information that I just mentioned before. So very important in Jupyter Notebooks, when you go from one cell to the next, the way to execute them is to use Shift Enter. So I do Shift Enter, I go to the next cell, I go to the next cell, and so forth. The important one is when you get here to the setup of the job description. And here is where you set up the TAPIS API that I just mentioned, where you define the job description for this API. And I will do that. So I'm doing that. Notice that it's taking a little bit of time to set up the job. And once it's done, it's going to give you a number. So the number means that it's been done, and there are no errors. If there were errors, the errors will show here. And then I will do something that is very dangerous. I will run this. So I just started the run here. And you will notice that when it starts the run, it's giving me an asterisk. I don't know what is happening. It's running. So now this is running in a Stampede. It's going to take 2 or 3 minutes. So bear with me a couple of minutes here. Now you say, is this running or not? Is this completely separated of DesignSafe, the CLI? You are in a Stampede. And actually, if you go to your DesignSafe and you look at your jobs here, you should, I should be able, oops, it's not showing right now, but I should have the, why is not showing this? Let me see if I do, oh, now it's doing a refresh. It's doing a refresh. And now if I look at, yes, it's running. You see, this job is running here. And actually, I can get information about the job. For example, what can I get? I can get where it's going to store. It's going to store in a folder with a weird number. So this is going to be dangerous for me because I don't know what is the data. So if I go back to where we were running, actually, I see that it's still trying to go through. And it should have taken just a couple of minutes. Let me see. Yeah, it should be done in a couple of minutes. And let me see if once it's done, and it's not done yet, what I will want to do is to post. Oh, it's done. Now it's finished. This is great. On the fly, it's not easy to do these things. So now I want to do the post-processing. So the first thing to do in the post-processing is to know where is that file. Actually, if you want from here, from the portal, I can actually say, oh, here it says that it's running. So I need to update this. So now it says that it's finished. So if I go here and I go to this folder and I say view, when I say view now, it's going to show me all the files that were generated. And so I see this monster folder name that I didn't select. It was selected by Stampede. And inside here, actually, I see all the input and I see all the output. So now I want to see this output. I want to post-process all this output. So that's why I am going here to the post-processing of the results. And so for the post-processing, I say first, I want to know the job info. Give me the job info. So go to the machine, monster machine, and give me the job info. From that job info, the only thing I want is the path. Where did you put the stuff? And it tells me the path. So if you look here, this is the monster path, including that monster name that I didn't choose. It was chosen by the machine. So I said, I need to go there. So from there, what I will do is to just choose my user here. I choose my user, and then I did a couple of OS operations inside my folder. So I did first tell me where I am. So it tells me where I am in the project. That was the original one, not the one that I just completed. Then I said, well, change directory, one back. And what I am going to do is to try to see if I can go directly with my Jupyter Notebook, if I can go to that folder where all the output was stored. And that's what these commands do. Suppose, for example, I say, well, but I don't know where is that. Where is that? What I can do here is maybe to insert another cell below, and I can say what is the current directory name. So when I run that, oh, it tells me that this is going to be the one. And so with this, you know where more or less you're going to be. And once you are there, what you can do is to run your Python scripts so that you can post-process the results. And in this case, the first thing that you have to do is to set up Python. So what I am importing is some of the modules for Python. So all the TAPIS stuff is already done. And what I am doing right now is to run a simple Python script. And the Python script here is going to generate, in a couple of seconds, is going to generate a plot of the acceleration on the response spectrum. Here it is. So what I had here is that is exactly this slide that shows you that you are going to do some Python stuff. You call a Python script, and the Python script is nothing but a Python script that you know how to use. And from there, that generates these output files. These output files are going to be output also in the Jupyter Notebook. I can continue post-processing the results. For example, I can create a profile of maximum acceleration, maximum shear strains. That's another Python script, and I can also use another one to generate pore pressures. So now, one important thing that I know that I have a couple of minutes more is how to generate a report. So for the report, look, it's very simple too. Now, I don't want to do Python for the report. What I want to do is LaTeX for the report. So for the LaTeX, I just call, or I say to the system, hey system, why don't you run PDF LaTeX? Why don't you run PDF LaTeX? And I have a document already set up there that is going to pick up some of the outputs. So, and that's what it's doing here. When I say go, now it's generating the PDF file using the LaTeX commands. And it gives me 0, meaning that it went. And then what I do is to just work a little bit so I can post this into the Jupyter Notebook. So I need to do a little bit of work so that the PDF can be posted here. So that's what I mentioned here when I indicate in my presentation that another thing that you want to do is to generate the report. I have a report.tex. That's a LaTeX file. If you know something about LaTeX, it's very easy, and from there I generate that. So I have a couple of more slides. I have only 1 more minute, but the other thing that you could do is also in the notebook to generate some interactive plots. And again, this is just a bunch of Python commands. And then the only thing that is important here is to use the interactive command. And for the interactive command, it's a Python module that you have to. And the beauty of this is that once you have this, in these notebooks, you can have something where you change the time here, and it tells you where you are. So just a little bit of interactive plots. And so I think that's more or less the end of what I had. I also had this idea of showing how to run many cases. And for that, you just need to use OpenSysMP. Don't worry about the TAPIS app. There is already a TAPIS app for OpenSysMP, but you need to have the correct input file for this. It's not a big deal, and I will have an example for that. And with that, the final comment is there is a ton of information about these TAPIS applications. One of them that I find very useful is this one. It's maybe a little bit old because it refers to Agave. Maybe now it's called TAPIS Pi, but it's not that difficult. And again, the app allows you to access this monster machine so that you can run your tool and get some results. So with that, I think that I will end my presentation. I know that we are just on time, and there were a couple of comments there, and if there is something, I can stay a little bit longer for questions.
There's one question there that I see in the chat there that I think I can answer. So Yang asks, I'm wondering if we should always keep the Jupyter Notebook open if the simulation is still running. Sometimes the simulation will take a long time to finish. So that's a really good question, actually. So you, I think you can. Yes, you can close the Jupyter Notebook, because once you submit the job using TAPIS, it's gone off to the supercomputer, and Jupyter is just waiting to hear, the response back. So, and just to clarify something, the Jupyter Notebook is not itself running on one of the HPC systems. It's actually just running on the TACC cloud. So it's just a VM in the cloud. So yeah, so it's a separate thing. So yeah, if your thing is going to take like a day or something to run, then you can close your Jupyter Notebook.
Very cool. Thanks, Julia. All right. Does anybody else have any questions for our panelists or for our presenters? So, okay. Only a couple notes I'd like to make. One is these are, of course, Boris, you can ask directly if you want to type the message in. It was too long to type. Not sure if I can unmute somebody's mic or not. I think I can. 1 second. Go to, there we are, participants. And Boris, one moment, and I will allow you to use your mic. All right, Boris, you should be able to unmute and ask a question.
Yeah, thank you. Can you guys hear me?
Yeah.
Yes.
Hey, Pedro, how are you doing?
Good, Boris.
So a question. So all this kind of looks a little complicated, to be honest. But the point that I'm trying to make is that for some of these simple problems, do we even have to go through supercomputing? What do you think, Pedro?
Yes. Well, first of all, Boris, this is an example that I want to run on the fly. Okay. So for running an example on the fly is I need this to run in 2 minutes. But the only difference between this and a very large model is just a TCL, you know this. And once you have to run this in a large model, then I suppose that you want to run 100 of those. Or then you say, well, I still have 50 processors in my regular PC. Well, what about 1,000 of those? And then this becomes useful. And immediately your question will be, how fast can you get in the queue? And you let the API handle that. But yeah, it's a concern. It could be a concern. So it becomes useful when you have to run many cases or large cases.
Okay, so I don't run many cases. I do actually have intrusive solution for this probabilistic problems. But the queue, so I had a bad experience over many years with queues for these supercomputers. So I switched over completely to our local clusters and local parallel machines. So what's the queue? I mean, how if you ask to run something that's large, it's going to take 2-3 days. How much do you have to wait? How long do you have to wait?
Yeah, it depends on what's going on with the machine, but you're completely right. Time in the queue is a problem, and then right now we have access for 48 hours in nodes.
I'm sorry, I didn't hear that. We have access for how many hours?
48.
Oh, 40.
That's the maximum. That's the maximum I can use.
So your run has to be below 48 hours, right?
I think so. For the regular user, yes. But of course, you can request access for more, but it becomes a different story. But yes, 48 hours has been, and just my experience. What I have tried to do is I try to do runs that take less than 24 hours. And then is when this system has been very useful for me. Because if I can run 1,000 cases in 20, and each one takes 24 hours, then in 24 hours I have 1,000 cases. So the next day I have a plot that shows me what happened with the simulation, and I can rerun everything again in one day. So that's when I think this has been useful. Now, I agree with you. Some other cases require 4 days, 5 days. This would not work.
Okay. Actually have a question for TACC people. So I have a program that I was supposed to install a couple of years ago. I talked to Ellen, but we never actually went through. So now I have it as a Docker container. Who do I talk to install real easy on TACC machines? Charlie, do you know, or who do I talk to? Oh, he's not listening. Okay, never mind. I'll send emails.
No, but do you have an account?
I think I do.
So,
but there was something wrong with it. Well, not wrong. There was a specific installation on TACC on one of those machines that actually tied together 2 libraries that were not supposed to be tied together. And then I talked to Frank, and Frank said that this is the way they installed it, and so it did not work for me because I had to reinstall everything from scratch, and I did not want to compile all the system libraries from scratch, so I just gave up. But now I have it as a container, so I can just. Anyway, I'll look for some of those old emails from Ellen. I'll talk to her. And actually, Tim, that's right, Tim Cockerill. I think I'll email him.
So that's the easiest. The easiest is to develop a Docker container for the particular binary that you have that works well with everything you have. Yep. One thing that I want to mention is that you can always, I have noticed in TAPIS, you can develop your own app, and the app is going to take the execution, the storage, and also the Docker container that you have in the particular TAPIS app. So it's very doable.
Okay, thank you.
There was another question there, or?
There was another question from Yang. Looks like Julia answered that. It was a question regarding getting the app ID for the application, and you can do that through, Julia mentioned, you can do that through the AgavePy, TAPIS command list in Python. So.
Or I would encourage people also to, you can also use the CLI, and the CLI is very, very useful for that type of thing. Like, for example, I did here just tap apps list, and it gave me all the apps that I have access to, and it gives the ID and the name, so it's very useful.
Give me a second, guys. All right. Are there any other questions? All right. Well, I would like to point out that all of our webinars are recorded, and you can go to our training archive on DesignSafe to rewatch any of the past webinars or to watch this particular one, which will probably be available in a couple days. If you have any questions in the meantime, feel free to hit us up on Slack. We're always there to answer any questions you have. Julia is there quite a bit. So, and I actually ask her a lot of questions as well. So once again, thank you, Julia. Thank you, Pedro, for the topics. It was really interesting, and I hope everyone got something good out of it, because there is a lot that DesignSafe offers. And if you take advantage of TAPIS here, it opens up a slew of new features. So thank you very much, guys. I really appreciate it. Everybody hit us up on Slack, and there's a URL for that. You should also get an invite to Slack when you sign up for DesignSafe itself. If you have any questions or suggestions for any other training in the future, email us at training@designsafe-ci.org. Also, you will be given a survey. There will be a survey sent out to you. We ask that you please take the survey. It's great feedback for us to build future webinars on. All right, and with that, thank you very much for coming. I hope everyone has a safe holiday season, and we will see you next year. Thank you very much, and have a great day.
Thank you. Okay.